In this short video, we're going to introduce two new technologies that will help us solve problems that we'll encounter in this course. And we're going to begin, or in this example, we're going to solve a problem we can already solve algebraically using logarithms, but we'll introduce the technologies. So here's the problem. If we invest $1,000 at 7% interest, compounded annually, how long will it take to grow to 4,000? So the first one we're going to talk about is the website Desmos. So I'm going to open a new Google tab, type in desmos.com. There's a link to it from our website. And it's a graphing calculator, so I'm going to start graphing. And we know the function, the amount function from compound interest. Desmos wants to work with y's and x's, so we will. So y equals 1,000 times 1.07 to the x. And then we're going to see where that intersects the line y equals 4,000. So when those two curves intersect, that'll be our answer. That'll be the time needed for the 1,000 to go to 4,000. Now notice we're not seeing anything here, and it has to do with the scale. This says y equals 1,000. When x is 0, y is 1,000, and that's nowhere here. So we have to zoom out a lot. And now we see the function coming in, but it's almost impossible to read. And look where 4,000 is. Now this actually, because of this dot being here, it might actually work. So I'm just going to peek, but then I'll show you what I really want to do. So yeah, actually if we just go up to where they intersect, we can see 20.49 is the answer. If that's all we cared about, we could stop now. I hate this scale though, so I just want to show you how to get a better picture. So if we go over to this tool and change the x-axis to go from, start at 0 and go to and go to 100. Now we get a much more reasonable picture. So on the x-axis we have the scale being much smaller, and on the y-axis we have the same big numbers because of the way the function is. So now we just get a much better picture, and let's show the grid lines. There we go. Okay, so now we've got a decent picture, and we can see sort of graphically that it's going to be near 20, and this is interesting. Let's see, so here's the intersection point, 20.49, 4,000. So the answer is 20.49. So basically we graph the function, the amount function from the compound interest formula. We graph the line y equals 4,000, and where they intersect, that's the solution to our problem. It takes 20.49 years for 1,000 to go to 4,000. Now we're going to solve it yet another way. And this one's kind of interesting. So we're going to go into Excel. And the first thing we need to do is to make sure that we have the solver add-in. So solver will allow us to solve equations in Excel. And if you don't have it on your machine, you go to File. Let's see, where am I? Yeah, File, Add-ins. Oh, terrific. What's going on here? Oh, Options. File, Options, Add-ins. Right here. Click on that. Excel add-ins. Yeah, that's what I want. So we hit OK. Oops, no, we don't hit OK. Sorry. File, Options, Add-ins, Go. Excel add-ins, that's what we want. And then we make sure that this solver add-in is checked. And on my machine, it already is. So once more, to get that solver add-in, you go File, Options, add-ins, go, click solver. Okay. Now we put the compound interest formula in, meaning what? Well, I'm going to make up a principal of 1,000, and then the rate is 0.07, and then the time, now I have no idea how long it is. Well, actually I do, but I'm going to pretend I don't. So I'm just going to put in any number here. I'll put in 5. And then A for the final amount after 5 years. And so now we're going to tell Excel to do the compound interest formula. So how do we do that? First we hit equal, which tells Excel to do a calculation. Then we click on the P cell, the 1,000, because that's what we want to multiply in our compound interest formula, times, and then the way Excel does raising to powers is with a function called power, parentheses, 1 plus this rate, 0.07, so that's the 1.07, and it's raised to the power of 5, so we click on this cell to get the 5, and we see that after 5 years, $1,000 has grown to $1,402.55. Now we could just keep on changing this t, maybe it's 10 years, and guess and check, but the solver add-in will do this for us. The way this works is we go to the Data tab, we go to the solver, and it says Set Objective. So that's the right-hand side of the equation, which is in fact this cell B4, where we are now, and we want that to have a value of 4,000. So we set the objective, the thing we're trying to achieve, to 4,000. And what are we allowed to change? Well, I could change the interest rate and see what interest rate I needed to do it in 10 years, but actually this is the one I'm going to change, the time. And so what I'm telling Excel to do is figure out what you have to do to change this cell in order to make this one, the amount, 4,000. And then we just hit solve. And oh, it found a solution for us, 20.49. And it says, do you want to keep that? And I say, yeah, keep that. Done. And we can see that we could solve multiple problems just by changing one of the parameters. Suppose I wanted to instead, suppose I set my time to 10, and this time I do say, well, what's the interest rate have to be? So again, I keep this at 4,000, but now instead of changing the time, I allow it to change the rate, 0.07. And now I solve, oh, and I need a rate of almost 15% to quadruple in 10 years. So that's how we use solver. And we will use both these technologies in the course for problems that we can't easily solve algebraically. So there we go.